Good day, everybody. Thank you for joining us and welcome on the 30th anniversary, I understand, of NEMEX. We're going to talk today about heat metering, pretty much a layman's guide to heat metering I'd like to bring to the scene. Just to let you know a little bit about Camstrup. We're a Danish company. We started in 1946, so again we have a lot of history behind us. And I was told some years ago by a very wise man that measuring energy was probably one of the toughest things that there is to do. Measuring voltage, current, things like that, that's reasonably straightforward, but actually measuring energy and measuring power is quite a difficult measurement. And I believe we do that pretty well. If you were here last year at NEMEX, you might remember this diagram. We called it the Bermuda Triangle. And the reason we called it that was that electricity has been metered very well for many years. That's a known technology. Gas has been metered for many years as well. We're all familiar with it with gas meters. But heat had eluded us. It wasn't really being measured particularly well in the past, and it's an important part of the triangle. So that's what we're going to be focusing on today in relation to the RHI. It was also true to say that until very recently, heat measurement was not particularly regulated in the United Kingdom. It hadn't been defined particularly tightly. The definition of a heat meter might even be treated by, and certain people would say, that the meter should be fair and just. But what does that actually mean? It was interesting when the RHI documentation came out, the initiative, sad to know, page 64, in there it actually specifically said that if you wish to claim monies in relation to RHI, that you would need to use an MID approved, which is, by the way, is the European Measuring Instruments Directive, Class 2 meter. What does Class 2 mean? It simply means that the accuracy of the meter is plus or minus 2%. If it was Class 3, it would be plus or minus 3%. If it was Class 1, which is quite difficult to achieve, it would be plus or minus 1%. So that's the meaning of the class of the meter. And it's you may find it interesting to note that in various countries throughout Europe, they don't necessarily use a Class 2 meter, they may actually use a Class 3 meter. So we're actually taking the accuracy up a little bit tighter here in the UK, leading the way as it was. The other thing about a heat meter is that it is calibrated in kilowatt hours and megawatt hours, rather like an electricity meter maybe. But there's a lot of other information that you can get from a heat meter which will be of use to you and will help you with your installation. Important information. In fact, there's a manager of a district heating scheme that I know very well, and he's actually said to me, to some extent, the information that he gets off the heat meter, other than the kilowatt hour, megawatt hour type readings, is probably more important to him in terms of running his network. So we'll show you some of those other parameters. Obviously, the kilowatt hour, megawatt hours reading is important here because that's how you're going to be, that's the reading. You're going to try and claim monies back from Ofgem. You would also, in relation to RHI, you may come across the discussion in terms of simple and complex installations, metering installations. Does that ring any bells to anyone? Simple, complex? Okay. Well, basically, what's actually happening is you have a situation where you have a heat source on the left-hand side there, and your load is comparatively near. So we're in the previous presentation talking about the need to have a load. It's relatively near, and the distance between the heat source and the load is defined, is relatively short, and therefore the losses can be quantified very easily. One thing for sure is Ofgem will not be interested in paying monies for the energy that you produce but the energy that you actually deliver to the load, the usable energy. Because the thing to consider is that in large installations there could be quite a loss from the heat source through to the consumer load. So it's important to use good quality piping, insulated piping, to make sure you don't lose heat into the ground or whatever. This is a typical installation of a heat meter. What we have is we have the heat source to the left of the screen. We have the consumer's load to the right of the screen, and you will notice at the top there is a unit in there called a flow meter. This is actually, it has no moving parts typically now. It actually uses ultrasonic technology to measure the rate at which the water's flowing through the flow part. And really, the equation is speed equals distance over time. The quicker the water flows, the quicker an ultrasonic signal moves through that flow part. So it's like transit delay. The interesting thing is, though, that the calculation is fundamentally interested not in the volume of water that's going through, but actually the mass. Okay, the mass. It's the weight of the water that we really want to get to. So what we have to do is we have to take into account the temperature of the water that's going through that flow part. We know the volume. If we know the temperature, we can actually take into account the difference in mass. The other sensors that we need, the other important parameters to understand here, are actually the flow temperature to the client and the return temperature from the client, because we need to know the temperature gradient across the load. And typically the hotter sensor coming from the boiler will be red, and the return one will be blue. So we're trying to make that as simple as possible for people to understand in terms of the installation of the sensors. In fact, if you put the sensors the wrong way around, the meter will give no temperature indication at all and not calculate energy. So it's important to get them to the right way around. You'll also see that the ends of the sensors are designed to cut through them, just extend past the middle of the flow of the water through the pipe. And that's quite important because it's amazing the temperature gradient you get not only along the length of a pipe but across its cross-section as well. So please take note of that. Normally with heat energy meters there are ample instructions for installation, so do follow those, that's important. These are the typical installations. The one in the top left there, that's a good one to do because it's you can put that on a bend of a pipe and it's actually sitting straight down the middle of the flow, so you're going to pick up the temperature gradient, and you need to pick up the temperature accurately in order to record all the heat energy that you will wish and hope to get payment for that you've produced from renewable sources. That's another sort of installation that can be done there as well. Where you're actually going on the side of the pipe. So there we are. We've got the flow meter and the sensors. What you should know about the flow meter is that because it tends to use ultrasonic technology. Why does it use ultrasonic technology? It's because meters that have moving parts in them are more susceptible to issues in terms of impedimenta, frictional losses. So what we're trying to do here is use a device which has longevity, needs minimum maintenance. But one of the things you have to watch out for is there's certain no-go areas in terms of mounting these meters in flow parts in a pipe. And typically, if you look at C on that diagram, this would be one example. The one right at the top, C, there's a possibility there that if you've got air in the system, you could get a build-up there and not actually record the flow of water. Typically, the way to deal with minimising air and cavitation in the system is to try and keep the pressure up, and we would expect 1.5 bar at least in the system to sort of keep that under control. The calculator, finally, the calculator is often known as an integrator, and the reason it's known as an integrator is actually at any given point in the day, a certain amount of power is being generated, but what we want to get to is energy. So actually the graph of time along the bottom, power on the vertical axis, the area under the graph is actually the energy. That's the kilowatt hours as opposed to the kilowatts. And that's an integration process. And that's what that calculator is doing. We talked about earlier on about the useful information that you might get off a system. You've just put your system in, you're firing it up, you want to make sure it's running okay. So the sort of information that's useful to see, for instance, is in the second column, working from the top down. You've got the flow temperature, okay, which is T1. You've got the return temperature, T2. And immediately you can see what temperature difference you've got across your load, which is the T1 to T2. And the interesting thing is that tends to be quoted not in degrees centigrade, but in Kelvin, because it's a relative temperature measurement, not an absolute temperature measurement. So if you see K and you wonder what that's for, that's the reason. The other thing which is useful is to see that the water's flowing through your system at a reasonable rate. Because if the water's not flowing through the system, you're not going to deliver energy to your load. So you'll see volume in litres per hour. And that's often used actually for setting up equipment as well. And then last but not least, what power am I actually delivering now? And that box at the bottom, 14.6 kilowatts as it says there, you can get that off the heat meter as well. So you'll see there's a lot of information available other than just measuring kilowatt hours and megawatt hours, which is going to help you. Last but not least, on this slide, you get info codes. So when you install the meter, it starts off with a big number. As you do the right things, like you fill the system with water, and you make sure the flow part's the right way round, because that's one of the things you have to do. That code, that info code, reduces to 0, and when you get to 0, you know it's functioning the way it should be. When that's all done, happy it's all running, seal off the system. Seal it, show that there's a point in time, line in the sand, where this system's been checked, is working properly, seal it off. It also, if you're putting in these meters for other people, it makes sure that people aren't going to should we say change things, whatever. If you want to read these meters remotely, there are various means of doing that. Typically, what's been done for some while now are wired systems. The common one that's used is a twisted pair of wires between meters on an M-bus network, and that's pretty easy to implement, actually, very easy to implement. And when you're using a pair of wires, you know they're there. You can also use wireless systems, and one of the devices that we find customers like very much looks like a memory stick, but what it actually is a wireless concentrator, so that you can get the information onto a laptop or netbook, and very cost effective. And I think the thing to remember, sometimes meters can be quite high up. So if you've got a meter for whatever reason it's high up, out of reach, and you can't read it easily, this little device will help you to do that. You don't have to get the steps out or trestles or whatever. The other thing that's happening with heat meters is the new wireless technologies, such as Zigbee, such as wireless M-bus, C mode. A lot of these meters don't have a power supply, and yet you want them to work for several years. So, for instance, the latest water meters coming out, they will work for 16 years, and they will send out their wireless reading every 15 seconds for the next 16 years. And that's all done in a meter which is this size with its inbuilt battery. It's very clever technology. I'd like to thank you for listening. I hope it's been helpful. And if you've got any questions, then please come and talk to us. Thank you.